Hello, this is Dr. Phil Rosenkrantz with a short presentation about how to incorporate IME 4030 into your senior project. This course is a finance course for engineers. We call it IME 4030 Financial Implications in Technical Decision Making, but you'll find this course in the College of Business. It's a finance course, and in most universities it's called engineering economics. Same kind of material, slightly different, but we're talking about the time value of money, discounted cash flow, compounding interest, and it's essential because companies want to know if the project you're working on will allow them to make a profit. So what I want to do is take a few minutes and talk about how you would use this, for example, and incorporate it into your senior project. And I'm going to use the senior projects that we do in the industrial and manufacturing engineering department as kind of my platform for this. So when you are doing a senior project, you're usually going into a company and they have some kind of problems going on. And these are open-ended problems. For example, your senior project might be to improve operations in the XYZ department, and they'll tell you the labor costs are too high, order filling is too slow, taking too long for changeovers or setup, there's not enough storage space, and there's too much scrap. These aren't the kind of questions you get in the back of your textbook. These are the real kinds of problems you run into in business. They're open-ended. And so what you have to do is have a strategy or a plan of attack for identifying the root cause problems. Then you have to come up with different alternatives for solving those problems, and then figure out the economics of each one and then make recommendations. So let's run through this using kind of hypothetical example here. So this is what they might tell you the problems are. These are general, but you need to find out what are the root cause underlying problems and attack those if you ever want these things to go away. So today in a lot of companies, you'll see them using Six Sigma methodology. They're using lean manufacturing. They might still be calling it TQM, which uses the same tools. And so these are different tools for identifying problems and then prioritizing them, finding the underlying problems behind those. And anyway, so let's create some kind of a plan of attack. So one of the first things you can do is talk to people. Walk around and ask people what their problems are, or if you mention one of these, you could ask them, what do you think the problem is? And you'll begin to get a sense for the kinds of things that might be the problem. But keep in mind that everybody's going to have a bias, but you can at least get a feel for what's going on. And then you might want to do a fishbone diagram for some of those problems with some of the people in the area to see if you can break down the problem into its most likely sources of problems or causes. Then you also want to do something where you can analyze the flow and look for bottlenecks. Usually there is a major bottleneck that's keeping a department from producing, getting things out the other end. There's usually a main bottleneck. If you can't find that main bottleneck, everything else you do is just temporary or only a minor fix. Once you find the main bottleneck, then you want to attack it. Now, what are some of the tools we use for that? Well, simply a flow chart is one. Another one is a value stream map. Those are good tools. And then also a spaghetti diagram. I knew I had that here. But anyway, out of these, you will have a chance to identify the bottleneck, and also you'll be able to identify where you have storage issues and where you have delays and where you can take out waste. Then some other things you might do is, with regarding the scrap problem, you might be able to implement SPC, do gauge R&R studies, and there you're looking to see if you're capable of producing things within specifications and if you're capable of measuring properly. And then you can do other things like design of experiments if you want to. And there's just a lot of different things that you can do to try and identify your problems. So let's say you do that, and what you're able to do is identify some of your major problems. And I'm going to erase this over here. And so what you find is that the three major problems you have is, one is in your storage area, your layout is poor, and things are piling up in certain places. There's blockages of egress. But if you could redo the layout and maybe get some new storage racks or storage systems, somehow that would solve a lot of your problems. Then also that you have a problem with your equipment layout. Again, from your spaghetti diagram, from your value stream map, you can identify that you need to fix that. And then the third problem might be that your machines are not capable of producing within spec. So if you could improve your storage layout and your equipment layout and get better machines that can produce within specifications, then all those other problems that were listed would be minimized or maybe even go away. These are the root cause problems. So now your senior project is to come up with alternatives for these solving these different problems. So I'm going to erase this over here, and let's kind of take a look at these. So for the storage layout, let's say that you look at different possibilities of how you could lay stuff out. You look at different types of equipment. Do you want to get roller racks? All kinds of different potential ways of changing the storage. And so let's say that you come up with a bunch of different ideas. You do some analysis. There's all kinds of tools, operations research tools for ranking alternatives and stuff. And let's say that your top two alternatives that you come up with is alternative one is you do a major layout, you rearrange, and you purchase one forklift for moving material around, and you add an operator for the forklift. And with this layout and with the forklift and operator, you'll be able to do your material handling and storage a lot better. And with alternative two, it's a little more expensive, but you're going to buy an automated storage and retrieval system. This is a set of racks with automatic equipment that can put stuff in and take it out and deliver it to a loading unloading point. But with this, it's more expensive as a system, but you don't need the forklift and the operator. So what do? You can't just recommend one of these. You have to do the financial analysis. Now you're into this course. So for alternative one, you make a cash flow diagram, and it's going to have the purchase price of the forklift. It's going to have the cost of the operators or the operator as some kind of a down arrow. And then you're going to have some kind of a benefit or a savings of some kind that you quantify. You can do that by estimating. That's a different topic. But from this, and then also you could have the salvage value of the forklift after some useful life of that you're choosing you work with, and you're going to get, using your minimum attractive rate of return, this is what money is worth to you, let's say 10%. This number is given to you by the financial people in the company. And when I worked at General Motors, our before tax MARR we were using was 15%. So let me put 15%. And then you do the same thing for alternative 2. You're going to have cash flow diagram, the cost of the ASRS system. You're going to have whatever the benefits or savings are. And then you calculate the net present worth. Now the net present worth for these are positive numbers if you're going to make more than the minimum attractive rate of return. And so if you have net present worths that are positive, the highest one is the most attractive from a financial point of view. So this is what you do for each alternative. For the equipment layout, it might be a little different. You might say, you might have, after you do all your analysis, you might propose for alternative 1, you do 5S, and then you do minor rearrangement. That would be your lower cost one. And for the more expensive one, you might do 5S also, but then have a major rearrangement. And this might be more expensive because of the cost of putting in footings, moving heavy equipment, who knows, or maybe even expanding. But you'll have these two costs, and again, you make your cash flow diagrams and calculate the net present worth for each one, and probably the one that has the highest net present worth would be the one that you want to do. But keep in mind that there are some other issues that could come up. For example, the major rearrangement might take longer, and that time delay costs money, and so that could be an issue. So you calculate these net present worths. And then for the machines not capable, let's look at what those alternatives might look like. Alternative 1 is you buy, say, 2 manual lathes and use 2 operators, 1 for each lathe. That's alternative 1. Alternative 2 is you buy a CNC machine and you have 1 operator. So the cash flow diagrams for these would reflect the initial cost of the lathes as present values, and then the operators would represent costs that would vary depending on the alternative, and then the benefits would be probably a function of how much output you could get, and then salvage value at the end. But you would again have a net present worth for each alternative. So in your report, in your written report, that you're submitting to management, you would list your methodology. You'd say what the problems were, and then your root cause analysis and the root cause problems. And then for each one of those root cause problems, you would explain the alternatives, maybe the analysis, and then your recommendations based on everything, including net present worth. And then you would make your recommendations on which alternatives you recommend, and you'd be able to give them a total cost, and you would also be able to show them what that means in terms of return on their investment. Now, these would all be in the written report. Now let me say something very important. If this is your senior project and you're making an oral presentation, say during the project symposium, you don't have to include all of these problems in your presentation. The reason being is you won't have enough time. You may only have time to present 2. And so the reason you don't want to cram them all in is because you'd be talking too fast, you would be blasting through it, and that makes it for a terrible presentation. You have to have a presentation that's presented in a comfortable speed where you sound like a professional. And what you can very easily do at the beginning is say, after you explain what the process you went through was, you could list all of the root cause problems and then say, all of these are covered in the written report. However, for this presentation, we are going to cover these 2. Nothing wrong with that. And then go through with, at a comfortable speed, your explanation of these 2 and your final recommendations. So what you want to do is you want to create confidence among your audience that you know what you're doing. You know how to proceed. And if you can show them how you analyzed 1 or 2 alternatives in a solid manner, they're going to trust you on the 3rd one, or they can always look at it in your report. Now, we have different schools of thought among the faculty. In your written report, you can include cash flow diagrams and calculations, but in a formal presentation, I personally don't need to see your cash flow diagram. I'm happy if you show me what the 2 net present worths are for your, say, your final 2 alternatives. You can have 3 alternatives and 3 net present worths, but I don't need to see your cash flow diagram. However, if your senior project advisor wants you to put the cash flow diagram into your presentation, then you do what they want you to do. So anyway, I hope that makes sense. If you don't have a financial analysis in an industrial and manufacturing engineering senior project, you know, if it's a research project, that's one thing, but most of ours are real problems. If you don't have an economic analysis, you will be called out on it. And you will catch some flack from the people from industry for not having it. So anyway, I hope you found that helpful, and good luck.